Welcome to Chapter 19 of sdm4. In Chapter 18, we talked about constructing confidence intervals for proportions. These allow us to kind of make a sense of what are plausible values for the population parameter, again, back in the population, based on sample data. In this chapter, we flip things around and think about testing hypotheses about proportions. And this is going to be more challenging, partly because it involves null hypothesis testing. We have to kind of assume the opposite of what we want to show, um, and then collect data and see how likely or more or less likely. It's the first time we're going to be introducing something called p-values, which are important but very, very difficult to be able to interpret at first go. So again, everything from 18, same kind of ideas. Now we're going to be using this to be doing hypothesis tests. So this bears careful reading because it's often a place where people will run into trouble. So hypotheses are described in section 19.1, and the idea of the null and the alternative hypothesis. If there ever was a good example of a place where you would want to kind of go through lots and lots of practice problems, I think this is a chapter where that's the case. There are lots of examples at the back, and I think those would be very helpful. This also talks at this point about the difference between a standard deviation and a standard error, which is an important distinction to be made. So the idea of a trial or courtroom as a hypothesis test is described here, and then really the interpretation and first definition of a p-value, which is really the probability of observing something this strange or stranger if the null hypothesis were actually true. And I'll give lots of examples. We'll have lots of times to practice that. It can be very challenging to be able to figure out. Again, we come back to the innocent defendant in the way. Just checking, as always, these are very valuable ways of making sure that you're on a good, solid footing. And I would agree with the authors here that you don't accept the null hypothesis. People make fun of you if you do that. You want to just either reject or fail to reject it. So the reasoning of hypothesis testing is very important. Kind of thinking about this first step of posing the hypotheses, positing some kind of model in step 2. There are mechanics of carrying out the test. And then finally, we want to go ahead and make a conclusion, as always, in the context of the problem. And so there's a nice example here of thinking about some alternative approaches. One of the things that comes up oftentimes in textbooks is the idea of a one-sided test. These tend to happen very, very rarely in practice. They are maybe thought to be easier for students to understand, but I don't think there will be a case in this course where I'll actually pose a problem that really is appropriately as a one-sided alternative. So I would be sticking with kind of two-sided alternatives. This example here with the step-by-step, I encourage you to kind of proceed through that in some detail and get the calculations. You can use, I wouldn't if I were you, the normal table. This is where the p-norm function, q-norm function can actually allow us to do pretty much anything we need. Again, go back to chapter 5 if you have any questions about that. So once we've actually calculated this p-value, we need to make a decision. What do we conclude? And we need to be thinking about that, and that's really the material in section 19.5. Another example, and this time from baseball, it takes us through and kind of thinking about 2 problems like that. Lots can go wrong, unfortunately, in this area. We need to kind of be thinking about the concerns and perils of testing, and so those we'll be talking more about as we proceed. But there's a nice summary here, as well as the learning outcomes and learning objectives for this section. Testing in this case is actually pretty straightforward. We've seen almost all the code we need. XP norm can be used to calculate the distribution of our test statistic under the null. The shaded area really is the p-value. We probably want to include both sides because of a one-sided, two-sided test. We continue through here using things like p-norm to be able to calculate those things. I actually do calculate a one-sided interval because the book does it here, but also generate on page 3 the two-sided interval. As I mentioned in the previous chapter, we can do exact inference. The same binomial test function that was used in the previous chapter can give us a p-value here of testing the null hypothesis. that the true value under the null is equal to 0.8. And we see that that p-value is very small. Our observed test statistic, our probability of success of 0.68, with a confidence interval that goes from 0.572 to 0.77. Sorry, goes from 0.57 to 0.77. Does not include 0.8, and so we would be less likely, we'd in this case reject that null hypothesis. Same code, everything put together in the same manner. Again, lots of different ways of thinking about both inverting confidence intervals and then looking at tests. They're really kind of two sides of the same coin.